Hi friends! You should be watching this video once you've made an attempt at page 47 in your unit packet. I'm going to go through the LOL for 47. So it tells us that two identical blocks are launched along a frictionless surface that's initially flat. The blocks then slide up a frictionless ramp. Block A reaches a higher height on the ramp than block B. So when I start making my LOL diagram, I don't really know enough about the initial. I'm going to start with what I do know from the prompt. The prompt tells me that they are identical blocks. That gives me an idea that they have the same mass, and that at the end, block A reaches a higher height than block B. I know objects that have the same mass and different heights will have different potential energies. So I'm going to show on my LOL diagram that block A has a lot of potential energy at the end and block B has less because it went less height. I also know that the prompt tells me that the surface is frictionless, so there will be no transfer in or out of the system. Therefore, I can assume that all of the energy that transferred into potential energy must have started as kinetic energy. So block A is going to have a lot of kinetic energy because it ends with a lot of potential energy. Block B is going to start with less kinetic because it ends with less potential. Notice how I've still shown a conservation of energy. Everything that I start with plus or minus the transfer is equaling everything that I end with. Now I'm ready to write my explanation. In order to answer the question above, the question is about which block has a faster initial velocity. I need to look at kinetic. That's the type of energy that relates to velocity. And I need to look at that at the start because it's asking about the initial velocity. Now when I start to make my explanation, typically what we've done is gone from left to right. But if I want to start talking about how I know the initial L, that this has more kinetic, this has less kinetic, I don't really have information in my prompt that leads me to that. So it gets tricky. It doesn't make sense to explain the initial L first because that's what we were trying to figure out. So will you guys flip to page 48 and we're going to write our explanation in a more logical order, and we're going to use the order that we figured out our problem in. So take a minute to transfer your LOL diagram onto page 48. It's the same scenario, attempt number 2. And when we write our evidence, we're going to write our evidence in backwards order. We're going to start with the information given in the prompt, and we're going to end with what it is that we circled that we need to figure out. So when I'm describing the final L, I know why I have more potential energy for block A and less potential energy for block B. It's because both blocks have the same mass and block A ended at a higher height. Therefore, block A must have had more potential energy. O is still going to be the same. We know there was no transfer of energy in or out because the track was frictionless. And now I can explain that initial kinetic. If block A ended with more potential energy and no energy transferred in or out, it must have started with more kinetic. This is the more logical way to do my explanation. Instead of explaining left to right, initial, transfer to final, I want to start with what's known, what's given to me in the prompt, and then end with the part that I circled at the beginning of my evidence section. So I'm ending with talking about the kinetic energy at the start. Now I can finish my explanation by circling the right claim and writing my concluding statement. My question is asking which block had the faster initial velocity. And I can tell if I have more kinetic energy with the same mass, then block A must be the block with the faster initial velocity. My concluding statement should include all those parts. Oops. Sorry about that. My concluding statement should say, block A starts with more kinetic energy, and it has the same mass, so it must have had a faster initial velocity. And that's because kinetic energy is related to mass and velocity. Flip over to the next page and try this example. You can pause the video while you're making your attempt. And now I'll go through it. So my prompt tells me that I've got a semi-truck with more mass and a car with less mass, and they're driving the same speed next to each other when they see a red light. That tells me information about the initial kinetic energy, and I know that the semi-truck must have more initial kinetic than the car because they have the same speed and the semi-truck has more mass. The prompt also tells me that they both come to a stop, and so I know at the end, the final, they have no kinetic energy. Well, and also for either part, they have no height because they're just driving along a flat surface. Therefore, I know in order to go from an initial with kinetic energy to a final without any energy, that energy needs to leave the system. And so all of the energy that the semi and the car start with end up leaving the system. The question that I'm trying to answer is, how does the force from the brakes compare? And in order to answer a question about force, the only energy type that relates to force is work, and work is only apparent in the middle of our LOL diagrams. So when I want to explain how I determine these energy transfers, I want to start with the given information and end with the energy type that I've circled here. So I'm going to start with what was given to me, the initial, and I'll end with the work in the middle. So for my initial L, I can say that both vehicles start on the ground with the same speed, but they have a different mass, so the semi must have more initial kinetic energy. Now I'm going to skip to the end, the final L. Both vehicles end on the ground at rest, so they have no final energy. And now I'll go back to that transfer. Here's what I'm trying to figure out. Therefore, the work out for the semi must be greater than the work out for the car. And that's because of conservation of energy. The only way you can start with more energy and end with the same is if more energy comes out. So now I can circle my claim. How does the force of the brakes compare? If they have different amounts of work and we know that they have the same stopping distance, then the one with more work must have more force. So the semi must have a larger force of friction. And when I write my concluding statement, I can include those variables. Since the semi transfers more work out and they come to a stop in the same distance, the semi must have used a greater force from their brakes. Notice that I've mentioned the work, the force, and the distance in my concluding statement. All right, keep going. Give an attempt to the next two LOL problems on page 50 and 51.